Alright, so this video is going to be part 3 of our ratio test practice. So, again, we want to prove whether the series converges or diverges using the ratio test, and here we have the sum from n equals 1 to infinity of n factorial over n times 3 to the n power. Okay, now, we set up our limit here. Alright, this should start to be familiar to you. The limit, as n approaches infinity, of the absolute value of a sub n plus 1. We plug in an n plus 1 for these n's to get a n plus 1 factorial over, this will be an n plus 1 times 3 to the n plus 1. We put that over our a sub n, which is just going to be n factorial over n 3 to the n. Now, all these terms here are positive, so we can eliminate those absolute value signs, and we move on to the limit as n approaches infinity of, we can now break this up into terms, okay, or into separate parts, I guess you could say. We have the n plus 1 factorial, that's going to be over n factorial. That's the first little part. Then you also have the n over n plus 1. And what else do you have? Well, you have this 3 to the n, that'll go to the top, and that'll be over 3 to the n plus 1. Okay? If you're confused on how I'm grouping this, I'm just putting, the factorials in the same place. Like this n factorial, what we made when we had to do the a sub n plus 1, we made a n plus 1 factorial. Okay, and that's going to go with the n factorial that, that n plus 1 kind of came from. So that's why I grouped it together here. Okay, and you're going to see that it cancels off really nice. So that's why I put them in the groups if you're confused about that. So anyways, the limit as n approaches infinity of this n plus 1 factorial over n factorial. What do we get here? Well, we know that this is just n factorial times n plus 1, right? And the n factorials cancel off. You're just left with an n plus 1 on the top. We're going to keep that next one, the n over n plus 1. And you're going to notice, of course, that this n plus 1 cancels off with this n plus 1. And you're also, well, what else are you going to get here? You have a 3 to the n over 3 to the n plus 1. When you end up subtracting here, you have a 3 in the denominator. So you get a 1/3. Okay? Now, that ends up just kind of writing it again so it's a little cleaner. We get a limit as n approaches infinity of n over 3. Okay? Now, that obviously is going to equal infinity, which means that this diverges by the ratio test. Okay? Quick note before we go to the next problem. I was debating on whether to do this, but I'm pretty sure you're going to have professors that are going to hate people who do this. But if you put infinity is greater than 1, you're kind of comparing an infinite value to a finite value. So you might get professors that go nuts over that or something. So I would kind of just avoid that. Of course, one of the conditions that I didn't really put down in the explanation video was that it's divergent if it's greater than 1 or equal to infinity. Okay, so that's kind of my fault for not including that, but just know that if it's equal to infinity, there you go, it's divergent by the ratio test, okay? That's one of the conditions. Alright, so we have our last problem here. We have the sum from n equals 1 to infinity of 3 to the n over n plus 1 to the n power. Now, you'll see here that this will actually be a little bit easier with the next test that we're going to be doing called the root test, okay? But never mind that for now. We got to solve this using the ratio test. So let's write our limit as n approaches infinity of the absolute value of, we get a 3 to the n plus 1 over, and this will be, remember, don't forget about that n right there. That's also got to become an n plus 1. So this is going to be an n plus 2 in the parentheses. And then you have an n right here, which of course also becomes an n plus 1. So that's going to be over 3 to the n over n plus 1 to the n. Okay, now we can get rid of those absolute value signs. Everything inside is positive. Let's make this into one fraction here. We get the limit as n approaches infinity of, this is going to be a 3 to the n plus 1 over 3 to the n times, it's going to be an n plus 1 to the n over an n plus 2 to the n plus 1. Okay, so you've seen this a million times in all our examples. This is just going to be 3. So we get the limit as n approaches infinity of 3 times an n plus 1 to the n over n plus 2 to the n plus 1. Now this is interesting because you're not going to be able to simplify this at all. So you kind of just got to use your head a little bit here. Think about it. You have a bigger number on the bottom. N plus 2 is bigger than n plus 1, right? That's what you have on the top. And it's being raised to a higher power, okay? So this denominator, eventually, as you get way up there, it becomes infinitely larger than this numerator here, all right? And that's going to mean that this limit equals 0, okay? 0 is less than 1, and that means that this is absolutely convergent, and therefore convergent by the ratio test. Okay, so just going to go over that one more time here, just because this is actually, I mean, it's sort of complex, I guess. You have a bigger denominator, okay? That's why this equals 0. This denominator is going to become infinitely larger than this numerator, meaning that this limit will go to 0. Okay, you have a larger thing getting put to a power, okay, the n plus 2, that's larger than n plus 1, and you are raising it to a higher power, okay, you're raising it to n plus 1 rather than n. That's why this goes to 0, which is, of course, we know, less than 1. That's why it's absolutely convergent and therefore convergent, okay? So that is going to do it for this video.
So if this video helped you, make sure to leave a like and subscribe by clicking my icon in the top left. You can also view the playlist for sequences and series, the explanation video for the ratio test, and the next video in the series. Lastly, if these videos are really helping you and you would like to consider supporting me, I have my Patreon linked in the description down below, along with some other pretty cool links that you should definitely check out. See you soon.